Welcome back everyone. This is the session 10 from the playlist of friction and the topic is Pulley block system. So in this session I have taken one case in which three masses are connected to each other by inextensible strings, and these three blocks are moving over this frictionless pulley. Now, in this case, I am considering that this mass is m1 is moving in the upward direction with a common acceleration a. That is, if mass m1 is moving upward with a common acceleration a, meaning that this mass m2 and m3 will be moving downward with the same acceleration. Common acceleration means that is the acceleration of m1, the mass m1, mass m2 and mass m3 will be the same. Now here this mass m1 and m2 are connected by a string, and this mass m2 and m3 are connected by another string. So in this case, in this example, m1 is less than m2 plus m3. That is, since this mass m1 is moving upward, it means that the combined mass of m2 and m3 will be more than the mass of m1. And as a result of it, this whole system of three block will move with a common acceleration a in such a way that the mass m2 and m3 will move downward and this mass m1 will move upward. Now, what is the condition for the mass m1 to move upward? Condition for the mass m1 to move upward. This mass m1 will move upward only when the force acting in the upward direction is more than the force which is acting in the downward direction. That is, now the force which is acting in the downward direction in this case is only its weight, that is m1 into g, where g is the acceleration due to gravity. Now we have to calculate the upward force. Now in this case, since this entire system of this three block is moving over a frictionless pulley, therefore, and since m1 and m2 is connected by a single string, therefore let us say if the tension in this string is T1. See, one more important thing which we all have to remember is that tension always acts away from the body. Now this is the body of mass m. So the tension will be acting away from the body, that is, it will be acting in the upward direction. This is very, very important. Tension acts away from the body. This is important. Since the tension acts away from the body, so this tension will be acting in the direction as indicated by this arrow. And since this mass m1 is moving in the upward direction, so this will happen only when T1 is greater than m1g. Or we can say that this block m1 will move in the upward direction when there is a net force acting on it in the upward direction. So what is the net force acting on this block m1? That will be equal to T1 minus m1g, and this will be equal to this is the net force which is acting on this body of mass m1 in the upward direction, and this will be equal to the, we know that force is equal to mass into acceleration. Here the common acceleration is a, here mass is m1, so m1 into a. So this is the first equation which I have got. First equation, that is T1 minus m1g is equal to m1a. Now let us let us consider this mass m2. This m1 and m2 are connected by one string. Now here the tension is T1, and as I have told you that tension acts away from the body. So now let us consider the this body of mass m2. So tension will be acting away, means that the direction of this tension for this block of mass m2 will be as indicated by this arrow, that is, it will be away from the body. Now second point, the weight of this block will be acting in the downward direction, which is equal to m2g. Now m2 and m3 are connected by another string. Let us say the tension in this string is T2, but for this block for m2, since tension always acts away from the body, so for m2, that is for the block of mass m2, T2 is what? It is the tension in this string. T2 will act in the downward direction. Okay, the weight will be acting in the downward direction, and since the tension always acts away from the body, therefore the tension for this block m2, for this block having a mass m2, will be acting in this direction, whereas the same tension for this block m3 will be acting in the upward direction, because tension always acts away from the body. For the block m3, for the block having a mass m3, the tension, this T2, will be acting in the upward direction, whereas for the block of mass m2, the tension T2 will be acting in the downward direction. So this is the most important concept here. So based on this concept, I will be deriving the second equation. For now, this block of mass m2 will come down or will move in the downward direction only when the net force in the downward direction is more than the forces which are acting in the upward direction. Now the force which is acting in the upward direction is only the tension T1, and in the downward direction the forces are m2g plus the tension in the string, because for this block of mass m2 the tension will be acting in the downward direction, because tension always acts away from the body. So this is the force which is acting in the downward direction, and the net force will be equal to this. This is the force which is acting in the downward direction, this is the force which is acting in the upward direction. So this is the net force which is acting on this body of mass m2. Now force is equal to mass into acceleration, so this is the mass into the combined, that is the common acceleration, which is equal to, which is a. So I have derived the second equation. First equation, second equation. Now consider this mass m3. Its weight is acting in the downward direction. See, weight always acts vertically downward. So in all these three cases, the weights will be acting vertically downward. So now this block will move downward only when the force which is acting in the downward direction is more than the force which is acting in the upward direction. Now in the case of this block of mass m3, the force in the upward direction is only the tension T2. And then, since tension acts away from the body, so the direction of this tension T2 for this block of mass m3 will be as indicated by this arrow, that is, it will be in the upward direction. So the net force acting on the block of mass m3, this will be equal to m3g minus T2, where this will be equal to m3a. So this is the third equation. So I have got three equations now. So I will be writing all these three equations here now. T1 minus m1g is equal to m1a. Second is this m3g minus T2. This is equal to m3a. And the second this equation, that is m2g plus T2 minus T1, this is equal to m2a. Okay, so these are the three equations which we have got, and now we will solve these three equations to get the value of common acceleration. So on the first equation, this is first, let us say this is the second equation, let us say, and this is the third equation. So from the first equation, T1 will be equal to m1 a plus g and from the second equation, T2 will be equal to m3g minus m3a. So this is equal to m3g minus a. So let us say 1, 2, 3. Let us say this is equal. This is the fourth equation, and this is the fifth equation. So what I will be doing, I will be substituting the value of T1 and T2 from equation number 4 and 5 in equation number 3. So I will be getting m2g. Now T2 is equal to what? m3 g minus a, and this T1 is minus m1 a plus g, and this is equal to m2a. Okay, this is equal to m2a. So I will be getting m2g plus m3g minus m3a minus m1a minus m1g. This is equal to m2a. m2g plus m3g minus m3a minus m1a minus m1g, which is equal to m2 into a. Now, with the help of this equation, I will be able to find the value of the common acceleration. So what I will be doing is, I will be taking all the terms containing a on one side. So m2g plus m3g minus m1g, m2g plus m3g minus m1g, this will be equal to what? This m2a plus m3. I will be taking this minus this term and this term on the right hand side of the equation. So a will be common, and finally I will be getting m1 plus m2 plus m3. Okay, m1 plus m2 plus m3. So finally our answer is, the common acceleration will be equal to from here g is common, you can write m2 plus m3 minus m1 divided by m1 plus m2 plus m3. So the most important thing which we all have to remember in this question is that tension, the first point, the tension always acts away from the body. The weight of the body always acts in the downward direction, and the body will move in the upward direction only when the net force is when the force acting in the upward direction is more than the forces acting in the downward direction. That is, the net force should be acting in the upward direction. Similarly, a body will be moving in the downward direction only when the magnitude of the forces acting in the downward direction is more than the magnitude of the forces acting in the upward direction. That is, the net force should be acting in the downward direction. Only then the body will be moving in the downward direction. So that was the second concept. So based on these two concepts, we were able to find the common acceleration, which is equal to G in bracket m2 plus m3 minus m1 divided by m1 plus m2 plus m3. So thank you very much for joining this session, and in the next session I will be discussing the same topic, that is the pulley block system, but I will be coming up with a different type of this pulley block configuration. So till then, have a nice day. Bye.